Module 13 study guide. I'm just going to go ahead and put that there and we will get started. In a chemical reaction, where is the potential energy and where is the kinetic energy? So we know that potential is where stuff is stored, and so that will be in the reactants. And then the kinetic is where the energy is active, and that is in the products. Number 2, if a chemical reaction has a positive delta H, will the beaker that contains the reaction feel hot or cold once the reaction is finished? We have been told in the book that a positive delta H is found in the reactants, and then the negative delta H is in the products, and we know that if we have energy in the products, that is exothermic, and which means that the delta H, a positive delta H, has to be endothermic. And all that means means that it is it'll be cold because it's absorbing the energy on this side. All right. Number 3, why is Hess's law a more exact way of determining delta H than the technique that uses bond energies? It takes account the phases of each. So it takes account the phases of each substance. Remember, we had to know whether it was a liquid or a solid or gas, because Hess's law wants to deal with the phases. Okay. What is a state function? Give examples. A state function is one that is independent of path, means it doesn't matter how it gets there. So it can do a variety of things and it still can get can still get to the final goal. So examples would be enthalpy, and then Gibbs free energy. Which of the following substances will have a delta H degrees of 0? Circle any and all. This is at formation. That F means formation. Well, we know that the only delta H at formation is of 0 will be things that are already formed. So O2 is already formed and Cl2 is already formed. H, and this is in gas, they're in their natural state. H2 is, if as a liquid, it's not in its natural state. It needs to be in a gas. O is lonely. It needs its partner, and so it's not in its, it can't have a 0. And a positive, it's an ion, so it's not in its natural state. And then, of course, this is a form. Number 6, which of the following diagrams indicates endothermic reaction? What is the delta H of both reactions? So remember, when we're looking at the final state minus the original. So we've got the ending minus the beginning. And in this case, it's 70, I would say, about 70 minus 15, and that equals a plus 55. All right, now let's look at this one. The ending is here, which is about 60, and the beginning is about 90, and subtract that, we get 30 kilojoules minus 30 kilojoules, because this is bigger, right? So we have a minus 30 kilojoules. That means this is exothermic, because our negative means automatically it's exothermic, and this is endothermic. Draw an energy diagram for the reaction that has a large activation energy and a delta H of 0. So if we've got our energy diagram here, we're going to put energy here and our what they call reaction coordinates or time here. Remember, our product minus our reactant in this case has to equal 0 kilojoules. So we have to start where we end. So if we start here, we have a large activation energy, and then we end at the same spot. The activation energy, remember, is what it takes to get the ball rolling, and that has to be large. So the hump is very large, but it ends where it starts. Number 8, if you have two 50-kilogram blocks of copper, and one is at the temperature of 50 degrees centigrade, while the other is at a temperature of 25 degrees centigrade, which has more entropy? Heat increases entropy. So heat increases, we'll just make an arrow, heat increases entropy. Therefore, the one at 50 degrees centigrade is going to be, has higher entropy. Right? So the one that has the higher temperature is going to have higher entropy. And number 9, if a chemical reaction is exothermic but has a negative delta S, what could you do to the temperature to make it possible to run the reaction? All right, so our formula is delta G equals delta H minus T times delta S. So to make it spontaneous, or make it run, so we have to make it spontaneous, delta G has to be negative. So delta G has to be negative, all right? Exothermic means that delta H will automatically be negative. So this is going to be negative. But since delta S is negative, the double negative will make, so this is negative as well. This will make this a positive. In order for this to be spontaneous, to run, this has to be negative. So you've got to make delta S as small as possible. And the only way to make delta S as small as possible is to lower the temp. So if this goes down, it will make this whole unit smaller, and that will make it more viable to run. So the answer is lower the temp.